Hi, this is Tony Mormino with Insight Partners, and to follow is an edited video of a webinar we did a few days ago where we toured the Miller Leaman water filtration product manufacturing facility down in Daytona Beach, Florida. It was a lot of fun. We hope you enjoy it. I edited it down just to the basics, so check it out. If you have questions on this product, no matter where you're located, you can contact me. All my contact information is below in the description. There's also some timestamps down there because we do, in the beginning of this, we do a PowerPoint presentation where we go through a few slides. But if you want to skip right to the factory floor and see the timestamps below, and you'll be able to do that. And please contact us anytime. All the contact info is below. Thank you very much. All right, so here's the plan. We're going to do a real short presentation. David's going to go over, I think, 4 or 5 slides. We're going to keep it super short because we really want to get down to the factory and see their amazing facility there and look at the live turbo disc demonstration. Then we're going to have a little question and answer period. And then we'll do at the end the Yeti cooler giveaway. Please note you have to be here to win the giveaway. All right. So we're going to spin this wheel digitally. And if your name pops up and you're here, you will win this cooler, and we'll get with you and we'll ship it over to you. So, and it's for domestic customers only. Please, I know we have a few international people on here. We greatly appreciate you joining us. But we're going to do the giveaway just for the domestic only due to the shipping costs. So, okay, next slide. All right, so David Romeo with Miller Leaman is going to give us just a real quick couple of slides, kind of pre-frame what we're going to be looking at in the factory, and then we'll go to the factory floor. Take it away, David Romeo.
Hey, David, I think you need to unmute again.
You're muted, Dave.
All right. Is that better? There we go. Okay, we're going to get to the cleaning of the cooling tower. We're excited to show you a demo downstairs of the turbo disc. We'll talk about the different micron levels. We'll talk about the manifolds we use and the controls. Right now, we're going to go to a slide, which if you want to proceed to the next slide, that would be great. Cooling tower itself. As we all know, that's the biggest air washer out there, is the cooling tower, bringing the air through the tower, collects all the different contaminants, a lot of organic material, and pollen, cottonwood seed, depending what time of year it is. And then, of course, anything blowing in the air, if there's construction nearby, sand, dirt, all sorts of things. You can find birds in there. You can find a lot of different things during the season when there's a lot of bugs. We're doing a big project right now with Regeneron up in New York, and they have a season where the bugs are extremely, they flourish, and they're always around the cooling tower, and they need to get those out of the cooling tower water. If you just take a look at this cooling tower, you have where the water comes down to the sump. It's pumped out as chilled water, goes to the heat exchangers, then the warm water goes up to the tower, sprinkles on down to cool it again, and the process starts all over again. We're going to be talking about side stream filtration, where we're pulling it out of the sump at a certain percent. Typically, the way that I design it to keep it real short and simple, say it's a 1,000-ton cooling tower, it's flowing approximately 3,000 gallons per minute. We typically take 10% of that, which is 300 gallons per minute, and do a side stream. That's also going to hit the numbers for your sweeper system. So, example, on a 1,000-ton cooling tower, the sweeper design is from Marley is around 286 gallons per minute at 20 psi. So we're right in that ballpark. We offer throttling valves on the discharge side of our equipment, which you can throttle back to meet that specification. The makeup water goes in the tower. We're constantly filtering 24/7. And then, of course, it's going to blow down due to the concentration of dissolved solids, not suspended solids. We're going to be taking care of the suspended solids. Anybody else want to fill in anything there, Tony, that I may have missed or anything? Okay, we'll go on to the next slide. This is an example of Insight insulation. We did talk about in the last slide about taking it off of the sump. In this case, there's 3 towers right there, 3 beautiful Marley towers, and they're taking it off the equalizer piping. So it's very simple to pull off that equalizer piping, then pump it on back through probably a series of sweeper systems in each tower. And then we recommend putting isolation valves on each sweeper system of the tower. So if you really want to enhance a cooling tower sump to really clean it out, instead of running that 286, it could be for each tower here, maybe, you know, shut one off and really blow off the other tower. It really gets it nice and clean. And you could do that periodically to really clean the basin itself. But in this case, it's a turbo disc taking off the equalizer piping, not the sump itself or the reservoir underneath the tower. That's a very nice installation right there. Next slide. 3 common filters. There's many filters out there, but these are the 3 common ones you see as side stream or slipstream on cooling tower. I would categorize them as kind of good, better, and best. So on to the next one, you'll see a centrifugal separator. Centrifugal separation is good, and it was initially designed for the mining industry because it takes out high specific gravity particles of 2.2 or larger. So that's kind of sand, dirt, anything like that. On a cooling tower, you know, only around 10% of the particles in a cooling tower is that specific gravity of 2.2 or larger. It's not going to remove any of the cottonwood seed, the pollen, the organic matter, or anything like that. It's going to spin right through. You know, have we used them? We have, but we use them as pre-filtration to heavy loading of dirt, and then the polishing would be a turbo disc filter. So, you know, if you want to remove roughly, you know, 10%, remember you're only taking 10% of the water. If you want to remove 10, 20% of the particulate, centrifugal separation will do, you know, a good job removing the heavy particulate. But to really polish the water and getting down to a much smaller micron, and centrifugal separation, I know everybody says it gets down to 74 micron, but there's not a barrier in that filter whatsoever. So it doesn't have they don't rate them for a micron level. They rate them for a specific gravity level of a particle that it can remove. Then we go on to sand filters. Sand filter technology has been around for hundreds of years. Of course, it works well. You're basically putting it into a block of sand. If you can think of it, it travels through the sand, just like it does to the aquifer in Florida and other states, and it gets some laterals, and then it gets pumped back to the cooling tower. Does a great polishing effect. It gets down to approximately 10 micron when it's brand new. The problem is if you have a lot of, say, calcium carbonate or anything like that in your water, or the water's hard, that bed of sand will start hardening. It'll become hard, basically, and the water then starts channeling. So your micron level will ultimately start going up a little bit. And we do sell sand filters. We sell quite a few, but again, we have sizes all the way from down to a 12-inch up to a 48-inch. We've also made some 56-inch if you need larger. But again, there's a lot of water compared to a disc filter. And if you're using your cooling tower water for that, then you're flushing out your chemicals as well. The next one is the disc filtration technology. Filtration was first invented by Boeing aircraft. They used it on the B-17s for hydraulic fluid, and it's been incorporated in the 1960s for water use, to filtering the water. It's a stack. I have an example downstairs, but different micron discs, different stack of discs that are built up on each other, and then the water travels through a set of grooves on the disc, which crosshatch, so you don't give a least path of resistance. And then in turn, it'll filter the water and polish the water as it's traveling through the disc, sending it back to the sump or sweeper systems, whatever you may have on the cooling tower. And we're going to give you a demo of that going downstairs. Example, we talked about backflush water use. On a standard 200-ton cooling tower, with the disc filter and the sand filter backflushing equal amount of time, you know, you can look at this. The sand filter will use, you know, over 2 million gallons per year of water, where the disc filter will use around 85,000 gallons of water a year. So again, if you're using city water, then you're just blowing all that city water down the drain. If you're using tower water, well, that, you know, 2 million and 85,000 is going to contain chemicals, which then you're wasting your chemicals. You also won't keep the chemicals balanced in a cooling tower with a sand filter that backflushes, because it's such a large amount of water. You blow down those chemicals, then your chemical charts go nuts, and they need to inject the chemicals in to keep it balanced, where the disc filter doesn't have that effect on the chemicals on a cooling tower. Live streaming now. We're going to move downstairs. Is that correct, Tony?
Yep. So thank you, David. That was a very good, concise explanation of what we're doing here, what we're going to see. So David and Sarah are going to get set up, and then we're going to switch to, instead of being in the presentation mode, we're going to switch over to their cell phone, and we're going to walk through the factory as a camera. So,
okay, we're going to walk downstairs. This is our sales and marketing area. And then we're going to work our way down there. This is to the right. Sarah's going to show you a conference room where we have our conferences for visitors. Let's take a look in there.
nice.
And then our general manager and our engineering area is just over here. It's kind of a duplicate of the sales department area. We have around 42 employees. The building was built in 1926. It was originally a bread factory. And we converted it in 1996 to our manufacturing facility. And we have 54,000 square feet. We're utilizing around 45,000 currently. So we're buying more equipment all the time, and it's taking more and more space. We're going to walk through the factory real quick before we get to the turbo disc. There you go. This is kind of the electrical and the controls area department. We have our strainers over here where we can ship out strainers quite quickly if you need one. Our Thompson strainer line, we can ship within 2 to 3 days or sooner if you need one. We're going to go around the wall. We have 3 major bays. We have one manufacturing, one assembly and testing, and one inventory. We're going to go to the manufacturing area.
This looks great.
Show you the.
Just to let you know, David and Sarah, everything looks great. We can see you and hear you just fine. Thank you.
All right. Let's take you through here. This is our screen department right here. Our screen department, we manufacture basically a frame that's made in a fixture. Then it gets perforation, and then we can spot weld any of the mesh or micron screen that they would need on the inside. So this is a completed 8-inch one right here. And as you can see, it has perforation for durability, and the screen that the customer chose on the inside where the water flows from the inside out. Take a look at that.
And for those of you watching, that is the Thompson strainer. So the Thompson strainer is a brand name. Miller Leaman makes that. So they actually make that in their factory there. So
exactly. And then we have basically a CNC shop over here where we can make any of the custom components that we have. So just give you a couple examples. These are made out of block of aluminum in this case, where we're making a manifold for a strainer. And then this is just a handle for some of our C strainers made out of 9010 copper nickel, and that was made out of the block, and we use our CNC machines to do all that. So we have 2 in this room. We have a back room, which we can manufacture different pieces of material. Take you through a quick walk back here. And then we have a printer. Okay. We have a printer where we can make up anything out of plastic, whatever we need to make ahead of time with this printer right here. There you go. Take a look at that. Work our way back. We'll do a quick loop of our U-shaped manufacturing area. We have a laser cutter, and then we also have a plasma cutter. So depending what we're cutting, we cut everything as a flat sheet. So all of our Thompson strainers are cut in the flat sheet, the inlet and outlet, and then they're rolled from there. We have different stations. I apologize we're putting some new air conditioner units in. So the guys are here working on those right now. But just want to show you something really quick. This is a seam. All of our seams are put on through this machine right here. And what it is that we can just install one of these units right like this after we take it, and then we can put on 100% penetrated weld right here for the seams of our strainers. And as you can see, we already cut the inlet and the outlet already out of these. Then we roll them and then seam weld them from there. Pretty cool how we can do that. We got cleaning process going on. There you go. We have different pieces of equipment. We have pipe cutting machines. We have other types of machines going on, cutting metal, making our flush ports, making our manifolds. And then this area right here is all of our custom area. In our custom area, we make all where the turbo discs are made and also custom filtration. So as you can see, they have a couple of pretty major strainers here going on a 165-foot Navy vessel or 165-foot Coast Guard vessel, whatever it may be. But that strainer right there is all made out of copper nickel. We'll show you a finished product here when we get to the end of the video. And we have some other machines. This is kind of a unique machine right here. We call it Big Red. And what it does is that it puts on certain welds. And it puts on the circular welds right here. And it puts on the top weld. And then anything else, our internal welds, and also our flange welds it can put on. But the unique thing about this, it's just like, you know, caulking your bathroom right here. It's a very clean weld, so it's a lot less cleanup and that we have to do. And you can scan over here, this weld and these welds and the flange weld. Okay, and we'll head over here. We're big believers in polishing. So as you can see, where a standard strainer would look maybe something like this, we polish our filters to make them look like this. And Sarah can show you that. That's kind of a finished polishing of the filter itself. Okay. Now we're going to head back to the turbo disc set up on the test station. I can't see if there's any questions, Tony or Chris. Is there any questions so far?
We don't have any in the chat at the moment, so you're still all good other than that one that you and I have already discussed about the micron level once you get to the turbo disc. Okay,
no problem. Thank you. This is a couple test stations. This is our test station right here for our Thompson strainers. As you can see, they're putting together an 8-inch strainer right now, and they'll pressure test it from there. And then the next to it is our test station for our turbo disc. And this is a turbo disc we're going to be showing right here. So what I would like to do is I'm going to start off showing you the inlet, outlet, how the water flows through the system, and then how it backflushes. This is the main pump. So of course, this is going to be set up either as a side stream or a slip stream. Side stream, we would be taking it right out of the sump, filtering it, and then putting it right back into maybe some sweeper systems, which I'll go through at a little bit more in depth, but we can put it back through a sweeper system if we need to. And what we do is we bring the water into the pump, which is located right here, taking it through, I'm going to call the bottom manifold my dirty water manifold. So that's my dirty water manifold located right there. As the water enters the dirty water manifold, it comes up the riser piping. Okay, these riser pipes are on both sides of the unit. It then feeds into the pod itself. Into the pod, when it enters the pod, we have a clear cover to show you how it backflushes, but it's just a stack of discs located right here. It does enter a helix effect at the beginning, which then spins the water. By spinning the water, we can keep a lot of the heavier particles away from the disc stack, prolonging the backflush. We're like in a sand filter. The dirt particles end up sitting on top of the sand. and then creating that pressure differential, then backflushing. I've seen it where we brought in sand and it just keeps it to the outside and it prolongs our backflush, so we don't have to backflush as often as a sand filter or other types of filters out there. Where then the organic or the floatable materials cling onto the disc, and you'll be able to see this disc get a little bit darker in some areas where they're going to cling onto the disc, because then the water goes through the disc, out this check valve, which is open during filtration, just like that, open, and down into the clean water manifold, which is right here. And the clean water manifold then sends it down to back to the cooling tower. We do have a small booster pump that's hooked up to the clean water manifold because we're using clean water to backflush ourselves. So in turn, we use typically a lower head pump than a sand filter coming in. So this system right here is 1,000 gallons per minute. It's going to Seagate, which is up in Minnesota, which is a company that makes chips. And then it has a 20 horsepower pump and a 5 horsepower booster pump, which is pretty remarkable for 1,000 gallons per minute. Excuse me. Yes, 1,000 gallons per minute. Had to check and verify that. So with low head pumps, then we're only running the flow pump all the time. The booster pump only is going to turn on during a backflush. So when that turns on during a backflush, it just pulls clean water off the clean water manifold, sends it through a booster manifold, which then backflushes 2 pods at a time. So pods here, 1, 2, 3, 4, 5. They're labeled on the other side, 1, 2, 3, 4, 5. So pod number 1 are going to backflush. 2 pods at a time will backflush. Anything on 6 pods or higher, 2 pods at a time will backflush. The other 8 pods in this case are still filtering water, sending it downstream. So we're going to start this up now to show you that. Any questions so far or anything? No questions? Yeah.
Hey, David, we did have one question. It says, does a turbo disc have to be mounted inside?
Hold on for 1 second. What was that?
The question came in, is this an indoor unit or an outdoor unit? Do they have to be mounted inside, or can it be either?
Either. They're designed to be mounted outside. We do have basically North and South Carolina is kind of our border. We kind of say anything up Virginia and North should be inside, but I have people in Minnesota that have them outside all the time. So, you know, it really just depends. They protect them underneath a tower or put them in a little shack or anything like that. But most of the time, you know, they're outside in the south and northern area inside. If we have to provide, our units need compressed air to backflush. We actuate our valves with that, and we put a little bit of compressed air at the top of each pod. If we have to, you know, provide an air compressor, we would like to see them mounted inside just to protect that air compressor as well. But you know, 90% of the time, a lot of them are outside. We're going to go through now. Sarah was visualing the helix effect, which is a spinning effect, okay, which then keeps a lot of the particles in suspension away from the disc pack. I don't know if you can see that, but what we're going to do is we're going to go through a backflush. And this one has an Allen Bradley controller, which is optional. Siemens is also optional. Our standard is our Maxim controller, which I'm going to show you that after this. But with the Allen Bradley, you can see how nice it is. It gives you basically the screen itself. I'm going to step over here, Sarah, if you can see that. It'll tell you the main pump running, the booster pump is off, manual start, fast forward, backflush, abort cycle. It'll give you the intervals, the backflush intervals in hours. If you want to change that to X, to 8, it's very simple to change. Differential pressure at 7 psi. The pre-dwell is at 5, and we also have transducers that are monitoring the system right here. Inlet pressure 22, outlet pressure 20, differential 1.3. And now we'll go through a manual backflush because it's not hitting a differential pressure. So what we're going to do is we're going to backflush. And of course, the first 2 pods go at the first, and then 8 pods are still filtering water downstream. What I'm going to do to speed this up is I'm going to fast forward to the last pod after we get it started. So I'm going to go into manual backflush start, which is a button I hit, It's now, booster pump is kicking on, and now it's going through a backflushing one pod at a time. I'm going to fast forward through it. Now it's going to number 2. Fast forward to number 3. Fast forward to number 4. And the next one's going to be 5. And I'm going to fast forward to that right now. So what you're going to see is you're going to see there you go. You're going to see it, the disc separate and the 120 jet spray out tangentially, scour and cleaning the disc, leave it on for a little extra time. It only takes around 10 to 15 seconds to clean the disc. I just left it on for a little extra time so you can see what it looks like. And now we're back into filtration mode. So let's do that one more time. I want to do that one more time. Manual backflush, and we'll speed through it. Number 1. Going number 2, 3, 4, and now 5 will go. And you'll see it kick into gear. Boom. Can you see
Nice.
that okay?
Yeah, looks great. Got a little feedback here. Oh, there it is. That looks good, David. Thank you.
Okay. Let me shut that off and that off.
David, I have a
Okay.
question. You'd mentioned sometimes these are installed under cooling towers, and there was a new design that was shorter. Can you talk
Yeah,
a
we
little
have
bit
a
about
low
that?
design. Yes, up to a 6 pod, we have a low design, which basically brings the pods from this level down to this level, just to fit underneath the cooling towers. That was a request from our reps throughout the United States for a lower design to fit underneath the cooling towers instead of having them outside the cooling towers. Just give them some additional protection. So up to 6 pods. Most popular is probably our 6 pod, 3 pods, 10 pods, 12 pods, and that's a little bit lower design than this.
You're kind of pre-answering questions now, David, because that was one of the questions. Is this setup typical of an installation with lots of pods, or is this a test stand? What is a typical? So thank you for answering that. So that question did come in, is kind of where you see that. But another question that did come in is, does this system come with a VFD standard on that primary pump?
On this one, it was requested to do a VFD standard on the primary pump, but again, our systems, we've already done studies on what's the most efficient if we want to use a VFD pump or the way we have it. And the way we have it with a low head pump running 60 hertz and the booster pump only coming on during a backflush is very efficient, because most of the time, if we wanted to run this at a lower amp draw, then lower hertz, then in turn the flow rate wouldn't be 1,000. It might be 800 or 900. Now that works out well when you have multiple towers, and maybe you want to shut off a few towers, because then you can hit different hertz levels for different flow rates for each tower. But most of the time they do not come with VFDs. This was requested by the customer to use the Yaskawa VFD. Our standard is Danfoss here, but they requested a Yaskawa. And that's one thing that we can do, is meet the need of the customer by them specifying, we want Yaskawa, we don't want Danfoss. Fine. We can still get Yaskawa instead of Danfoss. They also wanted, like I said, an Allen Bradley controller instead of the Maxim controller. So we can do that for your customers if there's any differences. And we have done it throughout, the country to meet the need for the customer. And then we also need to talk a little bit about the disc filtration. Just like sand filters or screen filters or any filters, you have an absolute number and then you have a nominal number. And the standard for our cooling tower is 50 micron filtration, which is our red disc. This is going to get down to 50 micron or smaller. We also have 50 micron, which is this disc, which will get down to around 30 micron. And we have 200 micron, 100 micron. We also have 20 micron, 10 micron, and 5 micron. The 5, 10, and 20 are used a lot on city water applications to get out sand or dirt, because they don't hold as much particulate. The holding level is very important for any type of filter to keep it balanced, and they backflush quite often. But on a cooling tower, we typically use our red disc, which gets down to 50 micron. And we do have some studies on that, independent studies made from Michelin Tire or other companies that GE has come in, and we can provide you with that information if you like to look at that. Okay. That should answer the Micron question. Any other questions you have? Now, we can also sell this as slipstream, which you're taking out of a pressurized line, then you're putting it right back in the pressurized line. And we would still use a pump on that. It might be not as high of a horsepower pump, because all we need to do is overcome our pressure drop and then push it back in the line. That's called a slipstream. We can also do full flow, where in some cases, like Whirlpool and GE and some of these companies want full flow filtration on their extrusion machine, injection molding, or whatever they're doing, where we don't need to provide the pump. We might provide a booster pump because they'll say, David, I need 1,000 gallons per minute and I'm only running 20 PSI. That's perfectly fine. We'll just put a booster pump on it to turn on one backflush. We will not provide the flow pump. So we can do that as well as a full flow design. So it's very versatile. Our largest system we've sold is 10,000 gallons per minute. So that was around 16 pod systems. So they were all manifolded together on one manifold. We're going to take a walk over here. I'm going to show you one other unit we're doing for Regeneron.
We have a question. I'm going to get you
a couple more questions, David.
Yep.
Okay.
So obviously we talked about indoor versus outdoor, and obviously you said you had some that are outdoor even in Minneapolis, but how about when you think about Atlanta, what is the freeze protection if you're doing a 24/7? So how do you operate and do that freeze protection associated with an outdoor application?
A couple things. First of all, keep it running. The only problem we've ever had is with freeze protection is with the air lines. Say they're not providing clean, dry air and you get some air in the lines and they sit stagnant for a while. It could basically freeze up, break the line, or the air won't flow through the line. And this system right here is going to Regeneron in New York. It'll be installed indoors, but they do want an air compressor on it. But being installed in New York, I'm perfectly fine with it inside with our air compressor. We used to have a problem with Murphy gauges, which is stagnant water lines that tell you the differential gauge. We now have gone to transducers around 5-6 years ago, and now we don't have that problem anymore. So keep it running. If it's in a cold Atlanta, the Carolinas, Virginia, keep it running. If it's on top of a building, we have some in Charlotte on top of the buildings. When they're running, they're perfectly fine. It's when they shut them off and they don't drain them or anything like that, then you have issues. But keep them running. If they want a freeze protection, we can show them a diagram of where to run the lines to put freeze protection on the units. Everyone's different because it could be a 3-pod, 6-pod, 12-pod, whatever it may be. You just expand from there. We kind of show you one pod and where you can run some lines. But again, the problems we have is with the air lines more than the water lines on any of the turbo disc systems.
Okay. And the other one is, can you be a little bit more and so some specific on the backflush flow path? I don't know if you want the unit in front of you or the one behind you that shows a good flow path.
Let's go back to the other one over here. The backflush flow path, good question. Basically we're going to go back to the pod that was being backflushed. This pod right here is the one you could see being backflushed. Coming from the dirty water side, this connection right here, it comes into the valve and the valve is open like an L like this, where the dirty water comes up into the housing, spins, filters through the disc, comes out, L back into the clean water side, back into this manifold. During the backflush process, what happens is that we take clean water off the clean water manifold right here, send it through a booster manifold right down through here. Of course, this would now be open. So what it does is it shuts. It's open straight across now, not at an L. Comes through the unit from the bottom. As it enters the unit from the bottom, it closes the check valve right here. Remember, it's open during filtration, closes it, travels up the spine, shoots out of the 120 jets, which are located on the spines right here. I don't know if you can get that, but each spine has jets on it, which then scour and clean the disc. Also, this decompresses, so it's compressed as it is right now, and it decompresses the disc to separate the disc, to spin and clean the disc. And then what happens is that water goes back out, the dirty water back this way, down through. Remember, this valve was an L. Now it's straight across like the other valve into the backflush manifold, which is right here. All it is a 2-inch backflush manifold. On the 10,000 gallon per minute system, all it is a 2-inch backflush manifold because you're only backflushing a certain amount of pods each time. Now, these backflush manifolds don't come together, so you have to pipe them together to a drain. Typically, a 2-inch, 3-inch drain is going to be perfectly fine. It can keep up with it because each pod at 15 seconds per pod is only going to backflush 12 gallons of water. So as a 10-pod system, it's only going to backflush 120 gallons of water. For a 1,000 gallon per minute system, that's pretty remarkable. Whereas sand filter would be around 3,000 gallons of water. So you can see the big difference of water use. And everybody's green these days. Our products are all greens. Our Thompson strainer has less than 1 PSI pressure drop across it, very green filter. Our Turbo Disc uses much less backflush water than sand filters or other types of filters out there.
Okay, here's another question for you that's a pretty good one, is can you put in the full Turbo Disc filtration system size for a cooling tower build out? For example, you put in day one, you're going to put in 1 tower and you're going to run at a low flow, and then you're going to continue to add. How does the Turbo Disc basically turn down? Can it be put in full size for that first tower?
Sure. And that's a great question. Thank you for repeating it. That's a great area where a VFD comes in, where say you have this 10 pod, but now you only want to run it at 600 GPM. You could have a VFD and you're probably only running then, probably 35 Hertz. And then as another tower goes in, you might be up to 44 Hertz or whatever. And then when it built out to 1,000, you might be running then at the 60 Hertz. Great question for that. We've also built them more in the wastewater industry than cooling towers, but the same applies, is where we can then take this end, instead of putting, we can put the booster pump at the other end because there's room for it. That would make this end have the discharge side. That would be the other side. And we can put blind flanges right here where then we could add 3 pods or add 4 pods or add 6 pods. We've done that before. And that we've done a lot in the reuse water industry. As the flow rates or the home sites build up, then they need to add more pods, and we put blind flanges on the ends, and then you could just expand from there. The only other part you got to expand is the solenoid rack, which is a good question. If you want to take a walk around the other side here, Sarah, and just show them the solenoid rack location, where it's on a dim rail, so it's real easy to change. But as you can see, all the solenoids are labeled 1, 2, 3, 4, and 5 right there. And we could also, when they actuate, I'm just going to go through kind of a fake backflush here manually. Should work. Oh, this has to be on. There. You're going to be able to see the solenoids react. So number 1 solenoid is actuating right now. It has a light on it. And then this is air override. That's the air at the top of the pod. And then when that solenoid is done, there'll be a 5-second dwell time, which is adjustable. You don't want any dwell time. And then number 2 will go. 2 will come on with the air override feature. Now it's the 5-second dwell time. Number 2 will come on, air override, and so on down the line. So by expanding the unit, we would just have to add more solenoids to that unit. The controllers are expandable up to 26 pods in a row. So we would use that same controller if it was 10 pods or if it was 26 pods. So we wouldn't have to upgrade the controller. Now I'm going to abort this cycle.
Specifically on the controls, obviously you've talked about that one being Allen Bradley. What are the interface capabilities that you have within the different control systems for BMS capability?
Really anything they would like. Most of the time we are asked for BACnet or for Ethernet. So they come with both, whatever you would like. You just need to let us know in advance what you want, because we're not going to provide probably a BACnet card unless it's asked for in advance. Ethernet is standard. That comes off the Allen Bradley Micrologics automatically. It's the BACnet card that we would have to provide for you. And that's all installed in there. The Ethernet plugs into the BACnet, and then the IPs, whatever, we give them the chart with all the IP numbers, and they can get any information they would want out of it, or emulate, just like we're doing here with the screens. They could do that too. So anything like that can be done with these screens. They're all touch screens. So you can take this screen, send the Ethernet out, put it on the control room, plug the Ethernet. This is the screen you're going to see. You can make all those changes. Now, granted, it's not like a chiller or maybe a cooling tower. It really should be locked down. The issues that we get calls on is when somebody's touching them and changing durations or changing this or changing that, then you have some issues. But if you want that information, such as pressures or anything like that, that can be all sent out through the BACnet or through the Ethernet, whatever you'd like. Okay. Did that answer the question?
Yep, that sounded great. So I know we've got some timing. So I've got a couple more questions, but we'll kind of save those and see how much time we have at the end.
Sure, we'll do that. We're going to head back up now. This is a unit that we showed you on the back side. This is a completed unit right here that we sell in the marine industry. It's all made out of 90-10 copper nickel. So you can take a look at that. We roll all this. We weld it all right here in our shop, and we have a contract with Bollinger and a couple other marine companies to install these in the ships that they're building. And then this unit right here is another Turbo Disc unit, another 10-pod unit. It has a disconnect on it. You can come over here. You can see the Maxim controller. The Maxim controller is what's normally provided on these units. It'll have a nice plate on there that says Maxim. I'm just showing you the inside right now. The motor starters are all UL, and then this one has a disconnect for this turbo disc, and they're putting that together right now. And then we'll move upstairs. If you want to ask a question now, that would be great as I walk.
Okay, one was to touch base on why we use an air compressor while other similar technologies do not furnish one.
Okay, well, if they have on-site air, they can just use that, and that's what I highly recommend, because if their air goes down on-site, they're going to, of course, fix it quite quickly. We use air because it actuates the valves much faster. It keeps our solenoids clean. And we also like to put air override at the top of the pod, because by flushing with air override, you're removing all the dirt and contaminants out of the unit, and we're letting our jet spray out into air, not water, which is a lot less resistance. So it's a big, huge benefit. The only people that should be using the hydraulic actuated valves are like in the agricultural industry. That's where it comes from, is they're using it, is in the agricultural industry. So this is another room I just wanted to show you. It's our demo room. So if anybody would like to come down and visit us, we can give you demos in our demo room. I'm going to start up one real quick here. It's just going to be a membrane system. But the thing I just wanted you to see is that we can take basically extremely dirty water and clean it right up with our membranes. And it's going to start up in 1 second here. So if you want to just go over there and show them the dirty water and then how we can clean it up into clean water. There you go. That's just an example of one of our membranes. We sell this quite a bit in the reuse industry. But you can see the left side is the dirty and the right side is the clean. Taking the turbidity right out of the water. This is our demo room. We're going to go into our, we call it the loft area. Our loft area is for our customers, all of you. If you come down to Florida and want to view our factory, you have a place to stay. We encourage that because we get to know everyone a lot better that way and bring in dinner, especially in this day and age. And this is our loft area where we can, play pool with you or shuffleboard or anything like that. We currently have 3 bedrooms, 3 baths. We typically have, matter of fact, Adam Parker, I know is on here, but last year we had some guys from the Insight team come down and spend some time with us during the races. So you're all welcome to, come in and visit us and stay with us as well if you like. Tony, you want to take it from there?
Thank you, David. And thanks, Sarah. Wow, that was really, really cool. I've been doing this for over 20 years, and I really just enjoyed. What a great way to get to know a company and a product. It was amazing. I really enjoyed it. Okay, we thank you for watching. Again, my name is Tony Mormino with Insight Partners. See below for all the contact information. Please like and share this video if you enjoyed it, and thank you for watching.